Okay, everyone, we're at section C and D of question 7. I've just copied back those sections of the paper onto here. We've done the cumulative frequency before, but since I've made a fresh copy, we're going to have to do this again. So here, what we have is 5 and then 5 plus 11 give you 16. Remember, cumulative frequency mean everything is accumulating. So it would have been a 0 here before. The 5 plus the 5 give you 5. Then the 5 plus 11 give you the 16. Then the 16 plus 26. So that is what would have been going on. Alright? So let's see. We have 5 plus 11 is 5 plus 11. That would give you the 16. Then we would have had 16 plus 26. 16 plus 26, that would give you 42. Remember, cumulative means everything is accumulating, piling up. The 42 that you had before plus 37, 42 plus 37. Let me redo this part, not very neat. I have 42 plus 37 equal 7, 8, 9, 4, 5, 6, 79. 79 that we have there plus this 9 would give you 88. Then the 88 plus this 2 would give you 90. Alright, good. Now the question says, on the grid provided on page 21, it's this graph paper which I had this grid which I had copied, using a scale of 2 centimeters to represent 20 kilometers per hour on the x-axis. So this is the x-axis. We're going to use 2 centimeters to represent 20 kilometers per hour. So we know that the x-axis will have speed in kilometers per hour. And 2 centimeters to represent 10 vehicles on the y-axis. So the y-axis, 2 centimeters to represent 10 vehicles. It will have cumulative frequency because they ask us to plot the cumulative frequency. You'd write cumulative frequency along here. It's kind of hard for me to try and write sideways on the computer. So let me put cumulative, CUF for cumulative frequency here. Draw the cumulative frequency curve to represent the information in the table. Alright, let's see what's going to happen here. On the x-axis, 2 centimeters to represent 20 kilometers per hour. Now, we start at 0 and goes up to 119. Alright. So, we start at 0. And then 2 centimeters to represent 20 kilometers per hour. Alright, we go, remember each of these thicker lines is 1 centimeter. Go 1 centimeter, 2 centimeters here, 20 kilometers per hour. So this is 20. Then 1 centimeter, 2 centimeters give you 20 more kilometers per hour. 20 on that 20 gives you 40 kilometer per hour. 2 more centimeters, 1, 2, gives you 20 more kilometers per hour. So the 20 and the 40 gives you 60. Then another 1, 2 more centimeters gives you another 20 kilometers per hour. So the 20 plus 60 gives you 80. Then 1, 2 more centimeters, another 20. So it's 20 plus 80, 100. We need to go one more. You have 1 centimeter, 2 centimeters, gives you 20 more. So 120. 120 here. Okay, good. We covered the x-axis. The values on the y-axis now. It says 2 centimeters to represent 10 vehicles on the y-axis. We start at 0 vehicles, goes up to 1 centimeter, 2 centimeters, represent 10 vehicles. So this is 10 right here. 1 centimeter, 2 centimeters to represent 10 vehicles, so that's 10 more, giving you 10 plus that 10 gives you 20. And 1 centimeter, 2 centimeters, another 10, so that's 30 here. 1 centimeters, 2 centimeters, 10 more give you 40. 1 centimeter, 2 centimeters, 10 more gives you 50. Let's see, we have some more to go. We need to reach 90. 1, 2 centimeters give you another 10, which is 60. 1, 2 centimeters more, another 10, 70. 1, 2 centimeters more, another 10, 80. Then 1 centimeter, 2 centimeters more, that is another 10, gives you 90. Good. Now, what they say you must do, draw the cumulative frequency curve to represent the information in the table. Alright. Let's see what the situation is right here. Alright, let me just bring back down my paper. Now, here you have 0 to 19, 5. What this means, 0 is the lowest value, and you're going to say that, you're going to imagine that 0 vehicles went 0 kilometers per hour. You're going to plot 0, 0, but guess what now? Speed in kilometers per hour could have been 0.1, could have been 0.2, 0.3, 0.4, 0.49, 0.4999 before you run it back down to 0. If it was 0.5 kilometer per hour, you round it up to 1, but I want 0. So imagine it could have been 0.4999. So you round it off at 0, 0, but you move just to the right of 0 kilometers per hour to show that it could have been 0.4999 or so kilometers per hour. Less than 0.5, because once you touch 0.5 you round it up. Now remember, don't use a dot to show the point that you're plotting. Use an X or a circle with a dot in it, right? Don't just use a dot alone. Technically you're not supposed to be able to see the dot, I guess. It has no thickness, alright? But the appropriate thing to do is use the X or the circle with the dot in it. Now, 5 vehicles went up to 19 kilometers per hour. But don't plot above 19. It could have been up to 19.5, but not touching it. Could have been 19.49, could have been 19.499, and you round it back down to 19. Could have been 19.4999, and to the nearest kilometer per hour you round it back to 19. So you're going to locate the point, the 19.5 line, but it goes up to 5. So 5, the 5 is this height right along here. Don't plot directly above the 19. Going to be halfway between 19 and 20. Alright, did my best to locate halfway between 19 and 20 there. The next plot, it would have been 16. The 16 height, this is 15, one more 16, so you're going to plot one height above the stick line here. Right, just to I put this here just to remind me how high I should go with the point. 16, so 20 to 39, it goes up to 39. So 39, and I should plot this height, but it could have been up to 39.5. It could have been 39.49, and I round it back down to 39. So don't plot directly above the 19, nor that 40. Plot halfway between. No, I don't plot directly above it. The 39 line or the 40 line is halfway between 39 and 40. Need to show those people that you know what you're doing and you know the rules of rounding off, right? Now, so that is my plot there. Let me rub out back my guideline here for the 42 high. I'm going to a height of 79. No, that was 16. I'm leaving out the 42. I want 42, a height of 42. 40, 41, 42. So later on I'll plot somewhere along this thin line here. Alright, if it was a real graph paper I could put my finger there just to remind me, but can't do that, so I just put this line here to remind me how high I should go with the point. Now let me look at where I should put it. It goes up to 59.5 using the upper limit. It says up to 59, but could have been 59.499999, and I round it back down to 59. So I plot above 59.5. So the question is, where is it? Close to 60. Alright, just to the left of 60. And I should locate it right here. So it's about here, halfway between 59 and 60. Then 79. How high is 79? Goes up to 80 and just one notch down. Alright, I should have a problem locating it later on. I won't bother drawing a line to locate my 79 high. Should easily find it. Now 79, above the 79. So where was it again? The height was 79, just a notch below 80, and I'm locating 79.5, just a notch to the left of 80. So it's right here. The next point 88, the height of 88, close to 90. Alright, just 2 below 90. And my speed here is 99. Okay, 2 below 90, just to the left of 100. It's 99.5, halfway between 90 and 99. I would say it's about here. No, a little bit too high. It should be about here. Kind of difficult to locate it exactly on a screen paper, much easier on a real graph paper. 90, that was 88, right? 88. Where was I? I had 79, then 88, and close to 100. Then I have a height of 90, so it's right along the 90 line. Where did I put my point a while ago? I missed my mark a while ago. Should have been close to 188. Alright, it's above 100 and close to 90. Yeah, 99.5 and 2 notch below 90, 99.88. So the upper limit is 99 that I would plot here, close to 100, or it's 99.5 that I actually plot, and then 88, 2 notch below, 2 units below 90. Then 90, right on the 90 line is where I plot next. 119 is close to 20, 119, so right on 90, but call it 119.5, because if it was 119.5, no, if it was just less than 119.5, like 119.49, would round it back down to 119. So you show that you know that fact, and you plot just to the left of 119, halfway between 119 and 120. So this represents our points. Now what do they say? Draw the cumulative frequency curve. So you do your best to draw a smooth curve. Alright, you do your best to draw a smooth curve through these lines. Oh my, I had gone a little too high here. Let me redo this part of my curve. Alright, so my cumulative frequency curve, I realize I missed here a little. Let me see what I can do about this part. Alright, so let's say this is my cumulative frequency curve. Alright, now on your graph, draw reference lines to estimate the speed at which no more than 50% of the vehicles drove as they passed the checkpoint. No more than 50% of the vehicles. That means you're going to locate halfway the cumulative frequency graph. All the way up is 90, so halfway up would be 45. So draw the reference lines to estimate the speed at which no more than 50% of the vehicles pass the checkpoint. I'm going to draw a line. Alright, use your ruler. I use my imaginary ruler, and I'm saying 45 is 50%. 45, go across to touch the line. When I touch the line, I go down. Looks like about 60, you know. Trying to estimate it. And you notice they say estimate because the graph is really an estimate, is not exact. When you do a calculation, that can be exact, but when you use a graph, it's estimate. As an estimate, to estimate the speed at which no more than 50% of the vehicles drove as they passed the checkpoint. So it looks like about 60 kilometers per hour based on this. So 60 kilometers per hour. Then what? Yeah, this is the reference line, and then what is the estimated speed? 60 kilometers per hour. I should write my 60 kilometers per hour down here. So it is 60 kilometers per hour. Alright, so seems like that's it for now. So I'll see you